In the 90s, Bill Gross had betted early on the internet, which rewarded him with numerous startups and a big fortune, and he has founded more than 150 companies since then. In 2020, Mr. Gross shifted his focus towards green energy by investing in Heliogen, as in his view the pandemic had decimated oil demand and leveled the playing field for green energy. Heliogen is modular AI-enabled concentrated solar power plants that have the potential to revolutionize the energy market by alleviating intermittency issues associated with the renewable sources of power generation. The refinery works by placing arrays of mirrors, heliostats, in a desert or a hot area. These are specifically designed mirrors that reflect the sunlight to a specific target. These arrays can be controlled using AI to make minor adjustments throughout the day to position them against the sun and efficiently capture the desired energy. These mirrors then reflect the sunlight to a receiver in the form of a giant beam, which can exceed over 1000 degrees centigrade and are stored using rocks in an insulated chamber. Furthermore, the stored energy can be easily transported and converted for industrial use, power generation, or to produce green hydrogen fuel to provide near 24-hour renewable energy that could replace fossil fuels. Heliogen is now heading towards commercialization, and in this regard have announced that it is entering into a definitive agreement for a business combination with Athena Technology Acquisition Corp. According to this agreement, Heliogen's leadership will remain intact. The deal values the combined company to be $2 billion and is expected to bring in approximately $415 million. These proceeds are expected to scale Heliogen manufacturing on a global scale and advance R&D for the next generation of heliostat technology. The companies are very optimistic and state that this will accelerate and advance Heliogen's mission to empower a sustainable future with low-cost, dispatchable concentrated solar energy and as an affordable alternative to fossil fuels. A study published in Frontiers has shed some interesting insights regarding greenhouse gas emissions and how the world's actions haven't been sufficient in its mitigation. Researchers from China took a sample of 167 global urban regions from 53 countries, which were selected based on their global coverage and representativeness in urban sizes and regional distribution. These regions were then analyzed through cataloging them in greenhouse gas emission inventories, their carbon reduction targets, and historical data regarding the change in their emissions. The results showed that though the majority of the sample had set clear and traceable carbon reduction targets, the world is far from achieving the targets set in the Paris Agreement 2015. The UNEP's Emission Gap Report 2020 has already warned that the world is expected to see a temperature rise in excess of 3 centigrades by the end of the 21st century, and even if prioritized by international communities, it could come below 2 centigrades, but not to the set target of 1.5 centigrades. Furthermore, the researchers also found that the 52% greenhouse gas emissions were from only the top 15 or 25 cities. These cities are mainly from Asian countries such as China and Japan, and EU countries such as Russia and Turkey. With regards to per capita greenhouse gas emissions, the study found that the cities in the USA, Europe, and Australia had notably higher per capita greenhouse gas emissions. It was also discovered that stationary energy is one of the largest contributors to greenhouse gas emissions of cities, which includes emissions from fuel combustion and electricity usage. Nearly half of the 109 cities had stationary energy emissions that represented more than 70% of their total greenhouse gas emissions, and more than 80% of the cities had stationary energy emissions that represented over 50% of total emissions. The authors conclude that to achieve the set target, cities need to transform from a resource-dependent industrialization path to an innovation-driven sustainable development path. For this, they state that several policies need to be implemented, such as more effective mitigation strategies to target key sectors, timely and consistent evaluation of the mitigation process, and more more ambitious and easily traceable goals. Speaking of environmental damage control, this week we have two technologies that aim to set a standard in their respective sectors. Our first entry is the recycling robot, which is in development by engineering researchers at the University of Sydney and is defined as a smart robot that can identify, sort and separate different types of recyclable waste. Although there has been a betterment in recycling plastic, soft plastics such as plastic bags have been an increasing contributor to the problem, with 94% going to landfill. Moreover, current procedures revolve around the manual sorting of soft plastics, as these can easily entangle in waste separation machinery, leading to mechanical failure and contamination of other recyclable materials. Thus, this robot would be able to accelerate the manual repetitive procedure by using artificial intelligence and computer vision to learn how to identify and sort different forms of recycling waste. Currently, the researchers are working with waste management companies and technology developers to build this robot and were awarded around $3 billion as part of an Australian federal government CRCP grant. Our other entry is the Lightyear One, a Dutch-made solar electric vehicle which has set a record for the longest distance travelled by an EV on a single battery charge. In June, the company tested their prototype on a test track in Germany and achieved a milestone of 440 miles in a single charge, the longest ever to be achieved on 60 kW of energy. The company states that at a speed of 85 km per hour, we drove for almost 9 hours straight on a single charge, and this initial run has surpassed their expectations and provided valuable inputs regarding improvements. The rollout of such technology would mean taking the EV efficiency to the next level and more affordable EVs. Well, that will be in its due time, but do let us know your thoughts on the environmental report and these new technologies.